Welcome to today's deep dive, where we're actually looking at something you probably have sitting in a tangled mess at the bottom of your desk drawer right now. I mean, usually a computer cable is like a $5 wire, right? So why are we looking at a cable today that costs $840? That is literally more than most high-end smartphones.
Yeah, it is a massive leap from a basic commodity to a piece of hyper-specialized technology.
Okay, let's unpack this because today we are diving into some really specific specs provided by HDTV Supply for the Avenview 50-meter 8K DisplayPort cable. And our mission here is to figure out, for you listening, is this just an absurdly overpriced accessory, or is there extreme engineering hiding inside that actually justifies the sticker shock?
Well, to understand why it costs so much, we really have to look at the brutal physics of what this specific cable is being asked to do.
Right, and I'll be honest, my first reaction to an $840 DisplayPort cable is just deep skepticism. Like, I can buy a 100-foot Ethernet cable to stream 4K video for 20 bucks. Why does this specific signal need a total engineering overhaul?
It really comes down to distance and data density. I mean, we're talking about pushing a raw, uncompressed 8K resolution at 60 hertz across 50 meters.
Which is 164 feet.
Exactly.
Okay, 8K is obviously a massive amount of pixels, but a standard copper wire sends electricity, and doesn't electricity move at nearly the speed of light anyway? Why can't standard copper just handle it?
What's fascinating here is why traditional physical copper fails over distance. So copper transmits data using electrical pulses, right? But the longer the copper wire, the more electrical resistance those pulses encounter. It's a process called attenuation.
Oh, sure, so the signal physically degrades.
Right. And on top of that, this cable uses the high bitrate 3, or HBR3 standard. That means it's pushing 8.1 gigabits of data per second down 4 separate lanes.
Wait, lanes? Like a highway?
Yeah, exactly like a highway. Inside the cable, there are 4 separate microscopic copper paths carrying these massive streams of data all at the same time.
Ah.
But over 164 feet, pushing that much electrical data well, the signal essentially dies of exhaustion. It just loses its voltage.
So it's not just a capacity issue. It's not like trying to blast a high-pressure fire hose of water through a twisting garden hose. It's more like trying to shout a complicated rapid-fire message to someone 164 feet away in a really noisy room.
That is a great way to put it.
Yeah.
By the time your voice actually reaches them, the energy is completely gone and it's just garbled noise. The display at the other end wouldn't even recognize it as a video signal.
Which means we have a big problem.
Right, and that sets up the strict necessity to abandon electricity entirely for the heavy lifting.
So if copper just dies of exhaustion after 50 feet, how do we physically get this massive 8K signal across a 164-foot room?
Well, we have to change the medium from electricity to light. This Avenview cable is an AOC, which stands for Active Optical Cable. It relies on a multimode fiber and copper hybrid structure.
Multimode fiber, meaning it can bounce multiple separate light signals down the glass at the same time without them crashing into each other.
Spot on. Think of it as a multi-lane highway, but for light. But to actually get the light into the fiber, you need hardware.
Wait, hardware inside the cable itself?
Yeah. There are literal microscopic computer chips and physical optical transmitters built right into the connectors at the ends of the cable.
Okay, here's where it gets really interesting. So this isn't just a dumb wire carrying a signal from point A to point B.
No, not at all.
The actual cable head plugged into your computer is actively translating the electrical video signal into microscopic light pulses on the fly.
Yes, and the head at the other end translates the light back into electricity for the monitor. It auto-detects the display resolution and handles the conversion instantly.
That is wild.
And to prove just how active this process is, the cable actually dedicates a specific one-channel multi-mode fiber purely for hot plug detection.
I saw that in the specs from HDTV Supply, and I was wondering about it. Why does just plugging something in need its own dedicated fiber optic channel?
Because in high-end AV, the source and the display are constantly talking to each other, verifying their capabilities. If you are hot plugging, meaning, plugging the cable in while the devices are powered on home, the cable has to instantly manage that digital handshake at the speed of light.
Oh, so the system doesn't crash or drop the resolution.
Exactly.
So what does this all actually mean for the person buying it? I mean, who is this for?
If we connect this to the bigger picture, think about who needs to send an 8K signal 164 feet. If you are setting up a sprawling sports bar or a massive commercial video wall, which is exactly HDTV Supply's specialty. This invisible infrastructure is what saves you.
Right, because failure really isn't an option when it's a high-stakes commercial setup. You can't have your screens go black right before the game-winning touchdown just because a copper signal got tired.
Exactly. And the price scales with the distance, too.
Mm-hmm.
If you need the 100-meter version, which is 328 feet, it costs a staggering $1,320.
Wow. It really puts the engineering in AV engineering. It's a completely different league.
It really is.
So, the next time you're out and you see a massive, crystal clear digital billboard or a seamless 8K video wall in a stadium, ask yourself, where is the tiny, hyper-expensive fiber optic translator secretly keeping that whole digital illusion alive? And actually, building on that, what happens to those fragile microscopic glass lasers when someone inevitably bends that incredibly expensive cable too sharply around a corner? Something to think about. Catch you next time.